topic 5, electronic configuration. We have two subtopics, which is quantum number of electron and also electronic configuration of an atom. And for this video, we will focus on topic 5.1, the quantum numbers of electron. We have two parts, and today will be the part 1. We have a few learning objectives that we will look into. First and foremost, what is actually orbitals? Orbital is actually the place where we have the highest probability of finding electron. In the other words, it's actually like the house of electron. Where the electron is located is in the orbital. So it's the area where we have the highest chance of finding electrons. Quantum numbers. We have 4 quantum numbers that we will look into. The first and foremost, principal quantum number, where the symbol is N. Second is the angular momentum quantum number, where the symbol is L. Third, the magnetic quantum number, where the symbol is M. Last but not least is the electron spin quantum number, where is the S, where the quantum number will be arranged in the form of N, L, M, S. This is a complete set of quantum number. And we will look very specific into what is each and every one of these quantum number means. First and foremost, principal quantum number. Principal quantum number indicate the energy level, or we call that electron shell. So it will tell us where the electron located. For example, this is your nucleus. So this is your shell number 1. Therefore, this will be labeled as N equals to 1. This is your second shell. Therefore, the N will be then equals to 2. This is the third shell. Therefore, the N will then be N equals to 3. So, the principal quantum number will show the electron is located at which energy level. Other than that, it also indicates the size of orbital. Means, it's 1s orbital and 2s orbital. The difference is N equals to 1, N equals to 2. Can you look at the size? The size is bigger. So when the N is higher, the size will be bigger. And it applies to all orbital. If you have a 2p orbital, means that my N is equals to 2, my N is equals to 3. And if you look at the shape, it's the same. But if you look at the size is now bigger. Because the N is higher, therefore the size is bigger. Next, we have angular momentum quantum number, where the symbol is L. So what is actually angular momentum quantum number? It indicates the shape of orbital. We have 3 shapes that we are going to learn in our syllabus. First and foremost, when the L is equals to 0, is a S orbital, where the shape is sphere. When the L is 1, the orbital will be P orbital, where the shape is in the form of dumbbell. When the L is 2, the orbital will be D orbital, so the shape will be in the form of clover leaf. But how do we know the number of L? How do I know that my L is 0, 1 or 2? The number of L will depend on the N just now. It will depend on the principal quantum number a moment ago. So, L will be equals to 0 until N minus 1. It means if my N is equals to 1, then my L will be 0. If my N is equals to 2, then my L will be 0 and 1. Because N minus 1 is 1. So we will start from 0 and end at 1. If my N is equals to 5, then my L will start from 0 until 5 minus 1, which is 4. So it will be from 0, 1, 2, 3, 4. So how about my n right now is equals to 4. So your L will be 0, 1, 2, and 3. Because 4 minus 1 will stop at 3. So your L will be 100% depends on the n number. Next, we have magnetic quantum number m. So, what is actually magnetic quantum number? It indicates the number of orientation of orbital. Orientation means arrangement. It shows the number of arrangement that we can have for each orbital. Bear that in mind, we have 3 orbitals in our syllabus. We have S orbital, we have P orbital, and also we have D orbital. And the m value right now depends on the L. And the m will be equals to negative L until 0 until positive L. What do I mean by this? When L is 3, then my m will be negative 3, negative 2, negative 1, 0, positive 1, positive 2, and positive 3. That is what I mean by this. So let's look into more example. So I have over here is my sphere. You know that when it's a sphere means that it's a S orbital. When in the S orbital, L is equals to 0. When L is equals to 0, m will then be equals to 0. Because m equals to negative L until 0 until positive L. So L equals to 0, m equals to 0. There is no negative 0 or positive 0. And if you look at your m right now gives you 1 digit. So 1 digit means 1 arrangement. And therefore, your sphere can be only arranged in 1 form. Another example that I have over here is your p orbital. So you can see over here, that is your p orbital. That is your p orbital. So I have 3 arrangement over here, 3 orientation. Why? Because when p orbital, L is equals to 1. So when L equals to 1, m will then be negative 1, 0, and positive 1. So if you look at it, m having 3 digits, negative 1, 0, and positive 1. Therefore, it gives rise to a 3 arrangement. And the 3 arrangement of the p orbital is your px, py, and also pz. They are having the same orbital, same shape, which is dumbbell, but they are now arranged in a different orientation. And the number of orientation will be depends on your m. Next, I have my d orbital. If you look at it, this is my d orbital, d orbital, d orbital, and d orbital. And if you look at on the screen, I have 5 orientation. So my m should have 5 digits. So let's see. When it's a d orbital, L is equals to 2. So when L equals to 2, m will then be negative 2, negative 1, 0, positive 1, positive 2. And if you look at your m right now having 5 digits. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how many arrangement we are having for d orbital? D orbital having 5 arrangement because of the m number. And that's what I mean by the number of orientation of the orbital. So the magnetic quantum number represents how many arrangements that we can do for that particular orbital. Simple. Last but not least, we have spin quantum number where the symbol is S, and this is the easiest one because S represents the spinning motion of the electron, and we only have 2. We only have positive half and negative half. This represents clockwise and also anti-clockwise. means that your electron can be in two directions only, where you can have your electron in a clockwise and also anti-clockwise. So as a conclusion, what is actually quantum number telling you? A set of complete quantum number include n, l, m, s in the bracket and having comma in between. And it indicates precisely the position of an electron in an atom, because n is going to tell you the number of shell, and L is going to tell you the shape of the orbital, and then the M is going to tell you arrangement of the orbital, and last but not least, S is going to tell you the spin motion of the electron. So a complete set of quantum number is going to tell you very precisely the exact location of an electron in an atom. Let's look into some example. The first and foremost, explain the position of the electron if I'm having this quantum number. So from this quantum number, I know that is my n, l, m, s. n equals to 2, and this indicates electron is located at the energy level 2. So it's located at energy level 2. L is equals to 1. So L equals to 1 means it's a p orbital. Bear that in mind. L can be 0, L can be 1, L can be 2. 0 is your s orbital, 1 is your p orbital, and 2 is your d orbital. So when the L is 1, L equals to p orbital, and your m is 0. We know that when L is equals to 1, m should be negative 1, 0, and positive 1. So right now my m is only taking 0. So it represents any one of px, py, or pz. Either one of the arrangement. Any one of the arrangement only. So S right now is negative half. And that represents electron spin at anti-clockwise. And because n equals to 2, L equals to 1, therefore it will be 2p. Next, that is my n. My n now is equals to 4 given. That represents electron at energy level 4. And you can see that L is 2. So when L is 2, it's a d orbital. And therefore, that will give rise to 4d. M equals to negative 2 means it will take any one of the d orbital arrangement. And right now, your S is a positive half, and that will give rise to electron spin at clockwise. And you can see that it's a 4D. Bear that in mind, that is your N, L, M, S. They will always be in the form of N, L, M, S. Next example. Write all possible set of quantum number for n electron in the second shell. Let's do it in the table so you can see it clearly. So, when n equals to 2 right now, your L can be 0, your L can be 1. And your M, when L equals to 0, your M will be 0. But when your L equals to 1, your M can be negative 1, 0, and positive 1. And the S will be forever positive half or negative half. And all the possible set of quantum number will be the first one, 2, because n is always 2 right now. And when my L is 0, my M will be definitely 0. And my S can be positive half. Or I can have 2, 0, 0, because n is 2, L is 0, M is 0, because my S can also be negative half. Or my n is still 2, because we are talking about the electron in the second shell. So n equals to 2, my L right now can be 1. So if my L is 1, my M can be either negative 1, 0, or positive 1. So we will take the negative 1 first. So if my n is 2, my L is 1, my M can be negative 1, and my S can be positive half. Or I can have 2, 1, negative 1, and negative half. Alright, can you see that now? So we are done with that. So the other arrangement that we can have will be 2, 1, but we are done with the negative 1 of positive half and negative half. So when L is 1, M also can be 0. And when M is 0, the electron can be in positive half or negative half. So we put only 1. And another one will be 2, 1, 0, and negative half. So we are done with the M equals to 0. We can move on to the M equals to positive 1. So same, I have the N is 2, the L is 1, so the M can be positive 1. And it can be positive half, or it can be negative half. And if you look at my answer, I have 6 possible sets of quantum number for an electron in energy level 2. Bear that in mind, every single set of this quantum number will show the position of one electron only. So n electron, therefore it will be in the form of all. Okay? So one set of NLMS quantum number is for one electron position. Last example before we end. Predict whether the quantum number is possible or not. First one, n is equals to 3. L can be 0, 1, and 2. So yes, it's possible. And when L is 1, so when L is 1, M can be positive 1, 0, negative 1. So yes. And S is a negative half. Therefore, yes, this is possible. Next, N equals to 4. So when N equals to 4, L can be 0, 1, 2, and 3. So yes, L can be 1. So when L is equals to 1, M can only be negative 1, 0, positive 1. So negative 2, no. Not possible. Why is that not possible? Because when L is equals to 1, M can only be negative 1, 0, and positive 1. Next, when N is 1, so L can be 0 only. So when L is 0, M can be 0. So S positive half, yes, possible. Last but not least, when N equals to 2, L can only be 0 and 1. And your L right now is 2, so it's not possible. Why is that not possible? Because when n is equals to 2, L can only be 0 and 1. And that's it for your quantum number. If you don't understand when you watch it for the first time, don't worry, watch it again. My little tips for you is, don't think too much. It's just a numbers that we will play around between the N, L, and S. That's it. Don't forget to hit the like button and subscribe to my channel. I'll see you again in the next video. Have a good day.